Alright, so we're going to start with standards G.1 and RP.1. They're closely related. G.1 is about scale drawings. So number 1, a scale drawing of an apartment is shown. What are the actual dimensions of the living space? And that should actually be requesting the dimensions of the living room. So one thing we notice is it gives us all the dimensions in centimeters, but it does give us a scale that 2 centimeters are equal to 11 feet of the actual dimensions. So we want to know the living room. We know it's talking about a width of 3 centimeters and a length of 4 centimeters. So I just need to find those values in feet by using proportions. So I can go over here, let's see, I'm going to zoom in a little and go over here to the left side and say, for this first one, 3 centimeters, if I know my scale is 2 centimeters is 11 feet, well then I can set up a proportion where 3 centimeters is x feet, and I want to know that dimension. So I'm just going to solve this proportion. To do that, we'll cross multiply. 3 times 11 is 33. 2 times x is 2x. Divide both sides by 2 to get x by itself, and we get that x is 16.5. So 16.5 feet by this dimension, the 4 centimeters. We know that 2 centimeters is equal to 11 feet in our scale. And we're looking to find out how many feet 4 centimeters is. And I know you can probably figure out another way to solve this, but we'll just use our proportion and say, okay, 11 times 4 is 44, and 2 times x is 2x. Divide both sides by 2, and we get that x is 22. And we're finished with number 1. Number 3, a map shows the straight line distance from George's house to his school as 9.5 centimeters. If George lives 475 meters from his school, what is the scale of the map? So the scale is just where I can figure out how many meters are being covered by 1 centimeter on the map. So let's just divide 475 meters divided by 9.5 centimeters equals 50. So 50 meters for 1 centimeter, and I could just write that scale out neatly and say, well, 1 centimeter is equal to 50 meters for my scale. Number 6, Miguel builds a model airplane with the scale 1 inch is equal to 6 feet. If the model is 9.3 inches long, how long was the actual plane? So I'm going to use that scale and say 1 inch is equal to 6 feet. And that is equal to 9.3 inches is equal to x feet, the actual length. So I'm just going to cross multiply and say, okay, 1 inch times x is easy. That's just x. And then 6 times 9.3 is 55.8. So we get 55.8 feet. Part B, the actual airplane has a wingspan of 39 feet. What is the wingspan of the model? So I'm going to start with my scale. 1 inch is equal to 6 feet. And at this time it's giving us the actual feet, 39 feet. So I'm going to look for x, the number of inches. I'm going to cross multiply and get 6 feet is equal to, whoops, I should have wrote that differently. We're going to get 6x is equal to 39. Then divide both sides by 6 to get that x is equal to 6.5. So 6.5 inches because it's looking for the distance on the model. Standard RP.1 is about unit rates. So starting with problem 1, Jacob runs 5 miles in 1.5 hours. Rupert runs 3 miles in 45 minutes, or 3/4 of an hour. Who runs faster? So let's find the speed. The speed would be in miles per hour. And I could change these fraction values to decimals. And that'll make this a little bit simpler to work with. And so I'm going to start with Jacob. Miles per hour. Miles for 1 hour is specifically what we're looking for. And so Jacob runs 5 miles in 1.5 hours. And we could just go to our calculator and say 5 divided by 1.5 is 3.3 repeating. So 3.3 miles per hour. That is Jacob's value. Now let's find Robert. Robert in miles per hour is running 3 miles in 0.75 or 3/4 of an hour. And when we say 3 divided by 0.75, we get 4 miles per hour. So who's running faster? The one that covers more miles? Robert. Number 2, select all the rates that are unit rates. They are per 1. So this one's not true. The second one is because it's divided by 1. This one's not true. The fourth one is divided by 1. And the fifth one is divided by 1. Number 4, Jenny is knitting a blanket. She knits 1/3 a foot of the scarf in 2/3 of an hour. How fast is Jenny's knitting speed in feet per hour? So feet divided by hours for 1 hour. Well, we know she's knitting 1/3 of a foot in 2/3 of an hour. So I'm just going to divide, and I can't change these to decimals because they'll be repeating decimals, and we want to be exact. So I'm just going to write it out this other way and say, well, 1/3 divided by 2/3 is like multiplying by the reciprocal to make this multiplication problem. It's like saying 1/3 times 3/2. And I could multiply across. 1 times 3 is 3, over 3 times 2 is 6, and 3/6 does reduce. Both the numerator and denominator both divide by 3, and we get 1/2. So she is knitting 1/2 of a foot per hour.